Yes, good morning students. Welcome back to 10th Science Unit 8 Periodic Classification of Elements Part 5. Yes, what we learnt in the previous classes? Let us recall. Modern periodic law, periodic properties, metallurgy, a metallurgical process 3 steps, important terms in metallurgy, types of an ore, and different methods of separation or concentration of an ore. Then properties of metals, that is physical and chemical methods. Then the extractive metallurgy of aluminum and copper. Now you come to the third metal, iron. Extractive metallurgy of iron. Iron, the symbol of iron is Fe. The iron has two valencies, 2 and 3. Now, occurrence. Iron is the second most abundant metal next to aluminum. It occurs in nature as oxides, sulfides and carbonates. The ores of iron are as follows. Ores of iron or minerals of iron. First one, haematite. The formula is Fe2O3. Magnetite, Fe3O4. Iron pyrite, FeS2. Now, iron is extracted from the ore hematite and it is called as the chief ore of iron. So, the chief ore of iron is hematite. Now, you have to extract iron from hematite ore. The formula is Fe2O3. Extraction of iron from hematite ore, Fe2O3. Now you have the 3 steps. The first one, concentration by gravity separation method. Here Fe2O3 is oxide ore. The oxide ore can be concentrated by gravity separation method. The powdered ore is washed with a stream of water. What happens? As a result, the lighter sand particles and the impurities are move away and the heavier ore particles that is settled down. This is the first step. Now come to the second step, roasting and calcination. What does roasting means? Roasting means the ore is heated in the presence of air, and calcination means the ore is heated in the absence of air. So, here the concentrated ore is strongly heated in a limited supply of air in a reverberatory furnace. And what happens now? As a result, the moisture is driven out and the sulfur, arsenic and phosphorus. Sulfur has symbol S, arsenic AS and the phosphorus P. So, these are all oxidized and it is an impurity, so it is oxidized off. So, this is the second step. Now, come to the third step. It is a very important step, smelting. The smelting takes place in a blast furnace. Now, you come to the diagram. Okay, now come to the diagram. Now, this diagram is the top of this diagram is like a cup and cone arrangement. So, it is like a bell and hooper structure. And what is in here? In this furnace, you have 3 region, lower region, middle region, upper region. Lower region, middle region, upper region. So, here you have different zones also. Here this is the in lower zone, middle zone, then upper zone. Here the furnace takes place in a furnace, the reaction takes place in a furnace, so the hot gases blast out. First, here you have to remove the slag, then you remove the iron outlet. The third step, smelting. The charge consists of roasted ore, which is the ore Fe2O3, coke. Coke has a symbol C, and limestone CaCO3, or in the ratio 8:4:1, and it is smelted in a blast furnace by introducing it through the cup and cone arrangement at the top. Now there are three important regions in the furnace. Now the first region, that is the lower region. The lower region is called as a combustion zone. In combustion zone, what happens here means the temperature prevails at 1500 degrees Celsius. Coke bonds with oxygen to form carbon dioxide with the liberation of a heat. Here the heat is liberated, so this reaction is called as an exothermic reaction. The second region, that is the middle region is called as the fusion zone. In fusion zone, what happens here means this carbon dioxide is reduced to carbon monoxide with coke. Here the reaction is prevails at 1000 degrees Celsius. So here carbon dioxide is reduced to carbon monoxide with coke with the liberation of a heat. Here heat is observed. So this reaction is an endothermic reaction. Here the next one, the limestone, the formula of limestone is CaCO3. If the limestone decomposes to form calcium oxide and carbon dioxide with the absorption of heat. Absorption of heat means it is an endothermic reaction. Then this calcium oxide reacts with silica. What is the formula of silica? SiO2. Now CaO, SiO3. This is calcium silicate. The calcium silicate is a slag. So in this outlet, first you remove the slag. Okay, which is the slag here? Calcium silicate. Calcium silicate is the slag. So first you remove the slag through the slag outlet. Now come to the third region, that is the upper region. The zone is called as reduction zone. The upper zone region is called as the upper region. This is a reduction zone. And here the reaction prevails at 400 degrees Celsius. What happens here means Fe2O3. This is ferric oxide. Here you have a 3 oxide. FeO means ferrous oxide. Fe2O3 means ferric oxide. Fe3O4 means magnetic oxide. Here this carbon monoxide reduces ferric oxide to iron. This iron is a spongy iron with the liberation of a carbon dioxide. Can you understand what happens here? The reaction takes place at 400 degrees Celsius. This carbon monoxide reduces ferric oxide to iron. This iron is a spongy iron. So now you balance here 2 Fe. So here I put 2. And here you are having 3C. So here I put 3. And 3 plus 3 is 6 oxygen. So 3 2s are 6 oxygen. In this way you have to balance the equation. Here what happened here means the spongy iron. Here this is iron, the molten iron. The molten iron is collected at the bottom of the furnace after removing the slag. So already you removed the slag. Now the iron is at the bottom of the slag. Now through this iron outlet you have to remove the iron. This iron is called as pig iron. This iron is called as what? Pig iron. The pig iron is remelted and you have to cast into different molds, and this iron is called as a cast iron. In this way you have to extract iron from the ore hematite. Now come to the physical properties of iron. What is the color of iron? Grayish white in color, and it is a lustrous metal. The next one, it has high tensility, malleability and ductility. It forms into sheets and wires. The third one, it can be magnetized also. Then the chemical properties of iron. The first one, reaction with air or oxygen. Here only on heating only the reaction takes place. So here on heating with iron, what happens here means iron bonds with oxygen to form Fe3O4, and this iron is called as ferric oxide, it is also called as magnetic oxide. So magnetic oxide has the formula Fe3O4. Now here 3 iron, so in this side you have to put 3. And here 4 oxygen, so here we put 2, 2 2s are 4. In this way you have to balance the equation. The next one, reaction with moist air. Moist means H2O, air means O2. So when iron is exposed to moist air, moist means H2O and oxygen means O2, and it forms a brown hydrated ferric oxide. The formula of brown hydrated ferric oxide is 2Fe2O3 dot XH2O. It depends upon the water molecule. So you have to put, generally you have to put X, and this formula is called as rust, and this phenomena is known as rusting. So this is, what is the formula of rust? 2Fe2O3 dot XH2O. So here iron 2 2s are 4, so here I put 4. Then here oxygen 2 3s are 6, so here 3 2s are 6, and here XH2O, so here you have to put X. Can you understand? So when iron is exposed to moist air, it forms a brown hydrated ferric oxide, and this formation is called as rust, and this phenomenon is known as rusting. The third one, reaction with steam. Only on heating, when steam is passed, steam means water vapor, so it has a formula H2O. When steam is passed over red hot iron, it forms magnetic oxide with the liberation of a hydrogen gas. Now, how many oxygen this side? 4. So here I put 4. But hydrogen 4 2s are 8. So here I put 4. Now iron 3. So here you have to put 3. In this way you have to balance the reaction. When steam is passed over red hot iron, and it forms magnetic oxide with the liberation of a hydrogen gas. The fourth one, reaction with chlorine. What is the symbol of chlorine? Cl2. Iron, when reacts with chlorine to form ferric chloride. In this place, this iron acts as a ferric chloride because it has the valency 3. Iron has the valency 3, so it forms ferric chloride. Iron reacts with chlorine to form ferric chloride, FeCl3. Now balance it. Here 3Cl, so here I put 2. So 2 3s are 6, so here I put 3, 3 2s are 6. Now balanced. Iron 2Fe, so here you have to put 2Fe. This is the reaction with chlorine. Now fifth one, reaction with acids. The first one, it reacts with dilute hydrochloric acid and dilute sulfuric acid. The first one, iron reacts with dilute hydrochloric acid to form ferrous chloride, FeCl2, ferrous chloride with the liberation of a hydrogen gas. So 2Cl, so here you have to put 2HCl. The next one, iron, it reacts with dilute sulfuric acid to form ferrous sulfate, FeSO4, ferrous sulfate with the liberation of a hydrogen gas. So this reaction is already balanced. The next one, iron reacts with dilute nitric acid in a cold condition. Nitric acid means HNO3. So iron, it reacts with dilute nitric acid, it forms ferrous nitrate, FeNO3 twice, ferrous nitrate plus ammonium nitrate and water. Now this equation is very tough to balance, so in near the nitric acid you have to put 10. Now you have to balance. 10H means, so here in this side already 4 hydrogen and 2 is there, so 3 2s are 6, 6 plus 4 10. Now this is balance. Then 10N. 10N means here only you have a 2, and this here you have to 3 plus 4, totally 4 nitrogen. So here I put 4 means 4 2s are 8, 9, 10. So totally 10 nitrogen here. Then oxygen 10 3s are 30. Now you have to check it. 3 2s are 6, 6 4s are 24, 24 plus 3 27, 27 plus 3 30. Then iron, lastly you have to balance iron 4 Fe. So here you have to put 4. In this way you have to balance the equation. So iron, it reacts with dilute nitric acid to form ferrous nitrate, ammonium nitrate and water. The next one, iron that reacts with concentrated sulfuric acid. Concentrated sulfuric acid is the formula H2SO4. Iron reacts with concentrated sulfuric acid to form ferric sulfate Fe2SO4 thrice. Here iron has the valency 3 and sulfate has the valency 2. So ferric sulfate with the liberation of a sulfur dioxide gas and water. Now you have to balance here. Here 3 sulfur, so here I put 3. So totally 6 sulfur. So in this side I have to put 6 and 6 2s are 12 hydrogen. So here I put 6. So 6 2s are 12. Now check the oxygen. In this side 6 4s are 24. Now check this side. 4 3s are 12. 12 plus 6 18. 18 plus 6 24. Lastly you balance iron 2 Fe. So here I put 2 Fe. In this way you have to balance the equation. The next one, when iron is dipped in concentrated nitric acid, it becomes chemically inert or passive. Inert means inactive due to the formation of a layer of iron oxide on its surface. Iron oxide means Fe3O4. It is another name, magnetic oxide. So this iron oxide forms a layer. So this iron, it does not react with concentrated nitric acid. So these are the chemical properties of iron. Now come to the uses of iron. Now here the first one, pig iron. In pig iron, it contains impurities of 2 to 4.5% of carbon. So this pig iron is used in pipes, stoves, radiators, railing. Railing means railway track, manhole covers and drainage pipes. The next one, steel. You already used the stainless steel scale, and this stainless scale, it contains iron and some other impurities, some other metals also. Here 0.25, less than 0.25% carbon. And the steel is used in the construction of buildings, machinery, transmission cables, TV towers, and also it's making in alloys, stainless steel alloys. The third one, wrought iron. Wrought iron means it contains the carbon content 0.25 to 2%. So it is a wrought iron. This wrought iron is used in springs. It's making springs. Anchors. Anchors means nanguram. And also it is used in the electromagnets. So these are the uses of iron. Okay students, now come to the assignment. The first question, explain the extraction of iron. The second one, write the chemical properties of iron. The third one, what are the uses of iron? These three questions you have to learn and write one time. Okay students, thank you.